At this stage, we can improve our ability to solve equations beyond just the linear equations that have the one variable in them, to incorporate the absolute value idea that we had used in our arithmetic review at the very beginning assignment. So the idea, again, with the absolute value is this math jail. What goes inside the math jail could literally be the math criminal. It could be a negative number that goes inside that math jail. And it could be a positive number, a wrongly convicted math number showing up inside that jail as well. So with those two different possibilities, those absolute value bars are kind of blocking us from being able to work our equation. In order to get rid of those absolute value bars, I have to consider these two different possibilities. That whatever is inside of my absolute value bars could have already been a positive number to begin with, or that what was inside of my absolute value bars could have been a negative number. So by considering both of those different possibilities, I cover all of my bases and come up with every possible answer, every possible solution that might work. So, for instance, a couple of direct examples here. If we just have the absolute value of y equals 7, well, the number inside of those absolute value bars could have been a positive, a wrongly convicted math number that when it gets out of jail is going to be that positive 7. So it could have started out as a positive 7. Or it could have been that the y that went into jail was a math criminal. It could have been a negative, and that means specifically it would have had to be a negative 7, so that when it gets rehabilitated in math jail, it becomes a positive 7 upon release. In this next example, I can't do this right away, but moving the 6 so that the absolute value part is by itself gives me a very nice way of handling things. So like that previous example, once I have that absolute value by itself, it becomes much more quick for me to tell what's happening. The absolute value of v. Again, I've got two possibilities. V could have been an innocent math number and started out as a positive before being convicted and going to jail. Or V could have been the math criminal before going to jail. So V could be equal to 4, or V could be equal to negative 4. Either of these would be a legitimate solution. Either of these would be correct. So in fact, we could say both of them are solutions. One more of these. The absolute value of z is equal to negative 12. Well, the absolute value, again, math jail, it's supposed to make numbers positive. It's supposed to rehabilitate, math rehabilitate any sort of numbers. So just automatically, when an absolute value by itself is worked out, it's going to have a positive answer, not a negative one. So this actually cannot happen because the absolute value cannot be negative. This equation cannot have a solution. So, literally saying so, we would want to watch out for this kind of situation here, because it is distinctly possible for it to show up. Which means that in general, what we're looking to do here, and let's bring up our list of steps. Since the absolute value part is the thing that's kind of the roadblock, or at least not a roadblock, but a speed bump along the way, Let's worry about getting that absolute value part by itself. If things can proceed with solving, great. I've got those two situations. Whatever is inside the absolute value bars could be the positive number originally, or it could be the negative number. But if I get that absolute value part by itself and I have a negative number showing up like that earlier example, I can automatically jump to the conclusion that my particular equation will not have a solution and be done with my work at that stage. And as we've said before with solving equations, it is always a good idea and frankly a wasted opportunity if we do not check our answers. So let's examine a lot of the different kinds of possibilities that we might have thrown at us. Let's keep those steps up here so we can see them for the first example. We want to get the absolute value part by itself. That's our first concern. And in this first example, the absolute value is equal to 9. I don't care at the moment what's inside the absolute value. I just care that the absolute value is by itself. And it is. That's been done already for us. According to the second step, we also can go ahead and work through answers because the absolute value is allowed to spit out a positive 9. That means that I have to worry about two different possible equations. What's inside the absolute value bars is a 4x plus 1, and that could have already started as a positive 9, or that 4x plus 1 could have started out as the math criminal negative 9. For each of those cases, I would want to solve. And then lastly, for each of those possible answers, I would want to check and make sure that everything does in fact work out so that I could then say, I do in fact have these two solutions. Down there at the bottom of the screen, I have x equals 2 and x equals negative 5 over 2. So let's work one of these live. Well, really several of these. Again, the first step is to get the absolute value by itself. Now, that is not already done for us in this particular case. What we would need to do is move the plus 3 out of our way so that we could get that absolute value of 3z plus 10 all by itself. Well, when we do that, we would have to get a minus 3 on both sides. And that means over there on the right side of our equal sign, 1 minus 3 would give us a negative 2. Like we saw just a few minutes ago, absolute value cannot be a negative number, cannot spit out a negative number, which means that we automatically are jumping to that conclusion that this equation has no solution. This is something we want to be on the lookout for. We do not want to just blindly move along without thinking about the steps that we are performing. The absolute value, no matter what it is that went inside this absolute value, no matter what z I tried to pick, the absolute value business is going to spit out a 0 or a positive number. There's no way on Earth or anywhere else in the universe that that absolute value is going to spit out a negative here. Since that can't happen, this equation has no solution. Be on the lookout for that. Yes, most of the problems that you're going to work are going to have nice solutions that you can check. And so if we consider, for instance, this one, jam you up with a little bit of fraction action, jam you up with having a number in front of the absolute value bar as well as a number afterwards, the first main step is still the same. I want to get the absolute value by itself. In order to get the absolute value by itself, I'm going to start by moving the 3 out front and the 2 at the end of my left-hand side. The quicker piece to move would be the 2. So I'm going to subtract 2 on both sides. That'll give me a 3 out in front of my absolute value bars, and that'll give me a 12 on the right side. Then I can go ahead and get rid of the 3 that's out front, and I will genuinely have the absolute value bars by themselves. Getting rid of that 3 out in front means that we would have to divide by 3 on both sides. So my absolute value is going to equal 4. This is totally legit. This is allowed to happen. So I have the two possibilities that come out of this. we have the stuff inside the absolute value bars that could have originally been the wrongly convicted +4, or we have the stuff inside the absolute value bars that could have been the rightfully convicted criminal -4. And so now we have these two separate equations that we would want to work through and solve, and that would give us excuse me, subtracting 1 and then multiplying by 2/3, we would get a = 2. And for the other equation, subtracting 1 and then multiplying by 2/3, we would get a -10/3. So we have these two answers that we would want to check. I would leave this to you to do. Again, a wasted opportunity if we do not do this. But if we go ahead and do that, then we should find that either by hand or with the assistance of our calculator, each of these answers plugged into the original equation that we have would work out correctly, and we would have two solutions, a = 2 and a = -10/3. Rather than leave you to your own devices with an extra little spin on the idea of these absolute value equations, let's talk about this more unusual looking situation. What if we had two absolute value bars showing up, one of them by itself on the left side of the equal sign, the other one on the right side by itself? Turns out that they're still the same two basic breakdowns, where we would, for instance, say inside stuff on the left equals inside stuff on the right. If they were actually exactly the same, positive equals positive, could be negative equals negative. But because of those absolute value bars, they could say, hey, wait a minute, the inside stuff on the left and the inside stuff on the right could have started out one of them positive, one of them negative. So just to make sure we cover all of those bases, that means that we do have a second possible equation to worry about. The stuff on the left could have been the opposite of the stuff on the right. So if we consider still only two equations, thankfully no more than that, we can try to work out what possible answers we might have. So in this particular case, we would say the inside stuff on the left, 3 minus 2x, could be identical to the inside stuff on the right, 3x minus 1. Or the inside stuff on the left, 3 minus 2x, could have been the opposite of the stuff on the right, the inside stuff on the right. So putting that negative and that set of parentheses in there to make sure that we've got everything all sorted out properly. Two equations to worry about. Let's see how those work out. If we go ahead and, add 2x to both sides and add 1 to both sides, we would get a 4 equals 5x, meaning that we would get x equals 4/5 for one possible answer that we would want to check. And in the other case, we would actually want to start out with distributing that negative. Distributing the negative, we would want to go ahead and add 3x to both sides and subtract 3, and that would give us x equals -2. If we go through the time and trouble of checking the x equals 4/5, since this one's a little bit more unusual, we'll do this one together. We're talking about the absolute value of 3 minus 2 times 4/5 is or is not equal to the absolute value of 3 times 4/5 minus 1. Excuse me. So we got the 2 times 4 over 5, which would give us 8 over 5. 3 minus 8 over 5 would need to be converted. 15 over 5 minus 8 over 5. 15 minus 8 would give us 7. 7 over 5, positive. Absolute value of a positive would give us a positive 7 over 5. Over here, 3 times 4 is 12. 12 over 5 minus 1. Well, we would want to switch that so that it would be a 5 over 5. So 12 over 5 minus 5 over 5. 12 minus 5 gives us 7. Over top of 5, the absolute value of 7 over 5 is 7 over 5. That all checks out. Yay. Then we would also want to check the second possible answer, x equals negative 2, and see how things played out there, where we would have the absolute value of 3 minus 2 times negative 2 is or is not equal to the absolute value of 3 times negative 2 minus 1. So we've got the negative 2 times negative 2 is positive 4. 3 plus 4 is 7. The absolute value of 7 is 7. Over on the right-hand side, 3 times negative 2 is negative 6. Negative 6 minus 1 is negative 7. And the absolute value of negative 7 is positive 7. So this is also checking out. Positive 7 equals positive 7. So this answer works, and we do in fact again have 2 different answers. The first answer we got was the x equals 4 over 5. The second answer that we got was the x equals negative 2. These are both verified solutions. And again, just to emphasize the idea here, we've got one final problem where we're using that same basic skill. We want to again start out by taking what's inside on the left side and setting that equal to the inside of the right-hand absolute value. 4t plus 3 is equal to 4t minus 5. Then we also have the second possibility here for how we could work out a possible answer, and that would be if the left and right-hand insides were opposites. So the left inside could be equal to negative parentheses inside stuff from the right. Well, in the first case, 4t plus 3 equals 4t minus 5. By subtracting 4t on both sides, we actually end up with 3 equals negative 5. That's false, which means that this particular half of our work is not giving us a solution. So let's check the other half of our work and see how things play out. What we've got showing up over there would be that we have a 4t plus 3 equals negative 4t plus 5. We'll add 4t to both sides and subtract 3 from both sides, and that'll actually end up giving us one and only one possible answer here to worry about. T equals 1 over 4. I will leave that to you to check out for yourselves. Again, very good idea for you to take advantage of that opportunity. And so if you do go through and check that out for yourselves, you should find that everything does in fact work, but that we only this time have one solution. T equals 1 over 4. Let's write that the same way we've been writing it with those other fractions there. T equals 1 over 4 happens to be the only solution in this particular case. So we just roll with the punches. We use the information that we know about how absolute value has to work and what it can do for us in helping us solve an equation. If it does actually allow us to solve an equation, we end up with 2 equations to worry about. Those 2 equations could have given us one solution each. Those 2 equations might not always give us one solution each. Sometimes they might give us no solution and one solution. So again, we roll with the punches, we work through our steps the way that we work through our steps, and we use our knowledge from solving linear equations and previous homework to help us along the way, and again, take advantage of that nice opportunity where we can check our answers.